Hello, everyone, and thanks for being here almost during lunchtime. I promise you won't regret being here, or maybe you will, but, well, I promise I will do my best to entertain you all. Okay, so first, I'll say something about myself. So, my name is Rob, yeah, here, right below the arrow. Now, wait to take the picture because the next one is better. And I work at the New York Times as an Android engineer. But actually, if you check, I'm pointing here to the cafeteria, which is where you can usually find me when I'm in the office. But as my colleagues can say, I'm not often in the office, right? Okay, so how many of you already used Android Kotlin extensions? Okay, so we all agree there is quite a bunch of magic in there, right? Okay, who says yes? Please raise your hand. More hands, more hands. Because I want this nope to hit as hard as it can. Because nope, there is no magic in there. It's just Kotlin, which is kind of magic language. But I mean, we're used to Java, so I mean, everything else is magic. So, okay. First, we set the first ground rule. We don't believe in magic, okay? If you checked out a TV series, which is actually pretty recent, called Deception, they always say magic lies in deception, which is what we're going to uncover in this talk. Okay, so let's get started. Let's get started. When I say that, you have to switch slides. Okay, so who can imagine what is this thing here? Just raise your hand if you can. I'll explain later because you cannot say anything. Okay, so this one is an animator, right? If we did that with Java, we would have to implement a huge amount of methods because we all love single responsibility principle, but not here. So, well, but if we use Kotlin extensions, what we can do is just invoke each of the callbacks like this. So we have a do on start, do on end, do on all these events I will never remember by heart. And all of these is obtained by using extension functions and a lambda. Okay? Don't you believe me? Please, when I say don't you believe me or don't something, just say no with your head. So I know you're still alive. Okay, so would you believe me? Please more no with your heads because I'm not going forward until you see all people nodding or say no. Okay, good. But now everyone, would you believe me? Okay, like this. Perfect. So let's check out how these actually work. So I took the doOnStart function, which is actually an extension function, and takes a lambda. The problem is that we don't really stop there. I mean, I've never seen that add listener function. So let's dive a bit deeper, and let's check how they actually could deceive us in this way. And actually, it looks like this is just a way to implement all the code we were trying to avoid. So, yep, no magic in here. What they did is just wrap the animation listener and add it right after its creation, and then create a set of extension function and pass the different function we see there on end, on start, on cancel, on repeat, so that every time we have a function that is not null, we invoke it. So if we declare, for instance, if we call doOnStart and doOnCancel, we're actually creating two of these, which is a reasonable trade-off. Okay, so we all used get system service, right? Did we? Okay, so Well, of course, we never use the type, but every other service was too long and wouldn't fit in my slide. And that's entirely not my fault, but I really love that how it looked like. So how can this work? I mean, we're not passing a parameter, or, well, actually, we have no parameters there. We are not casting anything. It's crazy, right? It's almost like magic. Say no with your heads. OK, perfect. You're still alive. OK, to do this, they actually implemented another extension function on context. So let's avoid the uninteresting part, that is the @requires API annotation and the get system service that takes a generic in there. OK? This is just normal programming. I mean, we all know about that. But let's check something way more interesting. And it's, well, this part here. Oh, looks like the generics was actually interesting. So, whoa, I never saw that functions there. Maybe they can help us. Right? Can you read them? OK, so let's check them out. So what does inline do? When we have inline, OK, it got. When we declare a function as inline, the body of that function is copied over to all our invocation of the function name. So let's say we have a function named Pippo, and inside we have 700 Pluto. Every time we invoke Pippo, our compiler will go, take the 700 Pluto, and pass them. OK? So we start to see how this can work. Because with Reified, what we just say is that, hey, please keep the type I'm passing you. And those two work together because we are actually not invoking any function. So there is no magic. We are just copying some code. And we say, hey, while you're copying, instead of erasing the type, please keep it because I'm going to need it. So it's really clear, right? Please nod with your heads because I cannot really read your reactions otherwise. So please. OK. So this is a very interesting point. So who of you already created a custom or compound view? Oh, you're really lucky if you don't create custom views. And every time I have to create a custom view, I ask my colleague to do that for me. And actually, he can nod in agreement. I'm talking to you, Walter. Not looking at you, but just nod. OK, so every time we need a custom attribute, we have to take a specific array and then recycle it, right? How many times, well, did someone ever forget to actually call recycle on any view? Yeah, I did. And every time I was like, why is this consuming so much memory? Yeah, that was for that. So what they did here is letting us take all the styles attributes we need without worrying about that. So, well, I mean, it's pretty cool. I mean, we are actually recycling the typed array here. I mean, we don't see it, but we're pretty sure it's doing it. OK? And actually, this part here does not really vary much from what we saw for the animator listener. So who thinks that this? Oh, it's not pointing. Well, the part between the curly braces is a lambda. Nobody says that's a lambda? Come on, people. The part between the curly braces. I can't reach that, but it's a lambda? Normal lambda? OK, let's say it's a normal lambda. Who says it's a lambda but not a normal lambda? Raise your hand if you think it's a normal lambda. Come on, nobody's raising hands, so you don't know what that is. Good, so I can explain it. So actually, it's not a normal lambda. That is called the lambda with receiver. Because what we are saying there with these two lines here is that we are telling our function, hey, everything I'm going to pass here will be actually executed on the typed array. So when you need to use it, you just need to invoke that extension function on the typed array object. So it's pretty cool, right? If you check the KTX library, you see that we have quite a lot of examples of these kind of use, because it lets us create a lot of function that can be then chained with the normal APIs, okay? So what happens is that when we take that lambda there and we invoke it, well, we don't know what it is, but we know it has something to do with the typed array, okay? And of course, in the finally, we're going to recycle our typed array, okay? It's all clear until now, right? Good, because that was the easy part. So, who loves some colors? Oh, thanks, Nicola. Luckily, I have you that respond to everything. Thank you. So, well, this is weird. I mean, we have like 4 letters, which possibly are color components, and an integer number, right? I mean, it's nothing else. I don't know how that could work. Well, let's see how actually it works, and then let's see how they make it work. So, of course, the first 2 digits there corresponds to the alpha. And that's pretty clear. I mean, we all worked with X values. Then we have the red, the green, and the blue, okay? It's pretty easy until here, right? Yeah, but how did they actually use that? Well, let's check it out. Whoa, it's quite a lot of code there. So let's get rid of what we don't actually need. So we know inline, right? We already saw it, so we don't need to repeat ourselves. But well, let's repeat. So when we see inline, that means that the body of the function is copied over, okay? Good, we don't need inline anymore. This annotation is pretty amazing, and since we are using these extensions, because we are dealing with extensions, we already saw them, this just said that this int on which we are creating the extension has to be a color int. The problem there is that this annotation has been deprecated. So there is not much information about that. But, I mean, it's pretty cool what it does. So let's highlight only what we actually want to see. OK. Good. We have a couple of keywords and a strangely named method. OK. So what does that mean? In Kotlin, we can overload the operators. That means that we can change what an operator does. So imagine that you want to write a library that every time someone uses the plus, instead applies the subtraction, and when they use the minus, it applies the addition. I mean, apart from the fact that that would be amazing, I mean, imagine how many bugs would you create by that. It's not the fact that you can. OK? So let's see how they could use these to get to what we have on top. So we have our extension function, right? So here we see that the components are named 1, 2, 3, 4. OK? This is not something we really need to create, because these components are actually created when we declare a model that has a specific number of parameters. And these components are numbered based on the specific order of the primary constructor of your class. That means that the 1 will be always A, the 2 will be always R, and so on, unless we change the order in the primary constructor. Okay? So, we saw that component 1 is actually corresponding to the alpha. And then we do some mathematical magic, which I don't really grasp, to get the first two digits. Well, it's easy. We just shift stuff around. But that's what happens. And this work, sorry, it skipped the slide, but it's okay. And this work because what we are leveraging here is that, I cannot pronounce that, but, well, Walter, can you tell me how to pronounce that, please? The disruptive declaration. Well, I can't pronounce it, but, well, so in Kotlin, you can tell to your code that when you have multiple parameters, you can grab them defining in this way. But I cannot pronounce the word at the moment, but it works in this way. When you have multiple variables like that, it will go in order and declare them all and assign the values based on the invocation of component. So when you have A, R, G, and B, it will invoke the 4 of them. But if you only want the alpha, this is not enough. So if you want the alpha like this, well, the only way to do that is to actually leverage another property of Kotlin, that is the extension property. So when we invoke the alpha property on any color int, there was the annotation there, I removed it, it will just invoke the same function that we used to take the alpha in the first place. So that kind of declaration we see on top can be used when we have all the parameters we need. Otherwise, we have to rely on something else. But as we can see, well, it's not really complicated. I mean, apart from the fact that we are actually repeating the same code, well, the rest is really easy. We can define any color and just grab what we need, because the same thing can be done, and it's actually done, for all the components. And also there are some extensions that will actually convert these back and forth, the X declaration we can use in strings. Okay. So, well, do you remember when we actually did not have paths? I do remember that, and it's not a good thing. So, well, now we have paths, so we're happy. The problem is that combining them is not easy. I mean, we are talking about drawing something on something else, and we don't have a pencil for that. So it's not easy. So to combine multiple paths, we now can use the plus operator there. We already saw that we can override the behavior of any operator by using a specific function. There's actually a full bunch of lists of functions that you can override so that you can implement the behavior you want for your operators. And what we do here is simply leverage the plus function and the operator keyword. So whenever we use the plus, it will instead invoke, well, it will always invoke a function, but it will invoke our extension function, and it will apply, it will create a new path and apply it this op method here. I'll be honest, this op method is not something that comes from the library, it's something declared in the framework itself, and I guess it defines the operation. And I'm usually okay with short names, but, well, this looks quite too short. Okay, so we saw the plus, but actually we can do the same in another way. And this is actually even more amazing, because we are not putting a symbol there. We are using a word. Like, and is literally a word. So there is another step that we can add in order to do these kind of tricks. And this is as simple as adding a single keyword. And this keyword is infix. When we use infix with a function that has one single parameter and one single receiver, we can call it in this way. That means we can put the function name without any dot, any parentheses, or any other symbol other than spaces between the receiver and the parameter. And what it does in this case is simply invoking the same sum operation we were using before. Okay? Okay, this starts to become complicated. Because, well, this thing here, when you saw that in Java, we'll start saying, what are we doing here? Why are we doing this? In Kotlin, it's actually slightly better. Because lambdas can actually access variables that are declared with an outer scope. And it's, well, I would say totally safe, but I don't trust anyone. So let's say almost safe. So it's not as bad as doing that with Java. So why is this important? Well, this example per se is not important, but it will help us understand what comes next. So just remember that when you see this in Kotlin, it's not as bad as when you see it in Java. Okay. Well, here we have quite a lot of interesting stuff, right? So we have an inline function and something that is cross-inlined. Okay, so study this part. Remember it very well because we're going to understand exactly why the cross-inline keyword is there. Okay? Are you ready? Okay, I see a lot of people nodding, so you're not asleep yet. Good. So, when we declare a lambda and we invoke another function, well, we cannot really just say return. I mean, we cannot. The compiler is not going to like it. So what we have to do is actually explain where we want to return. So we're going to say, hey, I want to return for just one level, because we cannot do anything else. Okay, well, there are ways to do that, but so let's stick with we can do anything else. But since actually this function is pretty long, we can add a label there. So we can name this ordinary function f1. And it's amazing the fact that you can put the at in front and after the word. Took me at least 5 minutes to understand why it was not compiling. But yeah, I mean, the at helps us declare a new label for any block of code. So you can use that for everything, for when, for with, for apply. Whatever you want, you can always label. Every time you have a block of code like that, you can always label in this way so that you can reference it later. Like, its return is not the only place where you would use the at annotation. There will be also this. So in case you have multiple these, this can happen. You can use the at annotation to choose which is the this you want. Okay? But if our function is inline, well, we can return in this way. But that's simple because this is actually not a real function. So when we are returning here, it's because we are copying the code, and the return itself is copied over. So, I mean, it's not a surprise, right? Okay. Let's check with a test. Okay, so the two returns, where do they return? Who says they return the for each? Who says they return the as zeros? Okay, you have to choose. Come on. Who says it's returning the for each extension? Raise your hands. Okay. Who says it returns the as zeros? Okay, you win. It's actually returning the as zeros. That is kind of contradicting whatever we just said, right? Let's check all the possibilities in which this can be true. And these possibilities are true when we have the Crossinline function, the Crossinline keyword. So, why I'm explaining all of these? Because in Kotlin we can have local and non-local returns. And actually, we have three different ways of, three different situations in which we actually can benefit of this. So, let's see the first example in which we have f2. In this case, only the local return is allowed. When we check f3, we say that when we use the single return, we're going to return from f1. While if we use the label, we're going to return from f3. And on f4, we are actually in the same situation in which we were in the f2 case. But actually, it's not really the same. Because, well, the first one, we just declare the first function, well, the function f2 as a normal function. So it has no knowledge of f. It only knows itself. So it cannot return from the enclosing function. It can only return from itself. In the second case, well, f3 is not really function. So it makes sense that it can return in different way. Because f3 is going to be a label. And when we say return from here, we are just saying, just go in this way. More or less like the goto and label works. In the final case, we actually are saying, yeah, I want you to inline my code, but I don't want my code to be able to actually return from the enclosing function. This is what the Crossinline keyword stands for. So when we find ourselves in cases in which we don't want our inline function to return from the enclosing one, well, this is where the Crossinline function comes handy. Because creating functions comes with an overhead. So most of the times, inlining can help us with performances. But usually, we don't care about where we return. In specific situation, we want to actually limit the freedom of the cross-inlined function. Okay? So, to recap it, we have two functions that are not really functions. Their code has been inlined in the enclosing function. And then we have other two functions that can only return locally. Okay, is this clear? Because this was the most complicated bit of the presentation. So if you made until here, well, it's all downhill now. So don't worry. Oh, wait, no, this was the other slide. Because, well, I might as well actually leave it. So, because now it's the point of the talk where I ask you if you believe that we can actually create and use the same kind of magic. And you say, no, we can't. So please, let's try this out. So, you know, we can create and use the same kind of magic. OK, so that's why the Darfan is there. So let's imagine that I have a view, and I want to show it in an animated way. I mean, of course, we could use this method. I mean, this function is totally fine. It works correctly. But I mean, we are on Kotlin. If we were to write this code, we would use Java, right? So there's a reason if we use Kotlin. And it's for the magic. OK, so let's transform this into an extension method. OK, slightly better. we can call all the methods of view right there. But now, my colleague arrived and told me, yeah, but now we also have to hide it. And of course, we could use the same animation for that. I mean, we just change a couple of values. That's going to work. Oh, I forgot a T there. Totally missed it. But imagine that instead, for some reason, we wanted it to animate in different ways. So let's check out how we can do that without copying over the common lines, okay? Because the duration is not going to change, and the start will always be called. Otherwise, we're not going to see the animation. So, well, this is how we can do it. So we already saw the something like the callback declaration. And actually, what we do here is saying, hey, this lambda declared on the view property animator is going to return the view property animator. Why we do that? Because if we want to chain the call in this way, well, they are all methods of the view property animator. So the only way to chain them in this way is to actually have an instance of the view property animator on which we can call the different methods, in this case, start. So now we have this function called update, and we declare there this lambda that will contain all the commands that we want to execute when we animate. So what's important here is that we only define, in this way, the commands that are needed for our animation. So we avoid all the possible boilerplate. Because we simply say, hey, this is a lambda. In this lambda, I'm going to return, well, the last thing that the last instruction returns, so that you can keep on doing whatever you're doing with the rest of the chain. So another interesting thing is that in Kotlin, when the last parameter of a function is a function, we can declare the lambda outside of the parentheses. So since there are no other parameters, we can also remove the normal parentheses, and this is how we end up with a cleaner syntax. So what we have here is that we declare the callback, and this is that. That is the callback. And we execute right in the middle of the chain. So it's pretty nice, right? So I think my time is over, because there's Davide there telling me to cut. So these are the people I work for. And we do a bunch of very interesting stuff. If you're interested in working with us, well, basically not with me because I'm never in the office, but with them that are pretty nice. Well, we are hiring. So come talk to us. We don't really bite. And I think we don't have any time for questions. So thanks for being here. And if you want the slides, they are already available at that address there. So thank you all and enjoy your lunch.